All right, so if you notice, I got the 4 points, right? A is at 2, 8. B is at 6, 8. C is at 8, 3. And D is at 1, 3. So now what we're doing is we are going to reflect it over the y-axis. So the y-axis is this one. So again, you're counting the spaces, right? So D is 1 away here. So it needs to be 1 away on this side. So that's D prime. Then do the same thing with C. So C is 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8 on this side, and this will be C prime. I want you to try B and A and see if you get the same thing I do. Welcome back. A should have been 2 away, and B should have been 6 away. So this would be B, and this would be A. And then we're going to connect the dots. And now we are going to write the coordinates for this one. So A now is at negative 2, 8. B is at negative 6, 8. C is at negative 8, 3. And D is at negative 1, 3. Okay? So you may have noticed, oh, our x coordinate is the opposite. So that's actually a rule. When you're going across the y-axis, the x coordinate's the opposite. And if you're going across the x-axis, the y coordinate is the opposite. Sorry, let me go back up. If you go across the x-axis, it's the y coordinate that changes. So again, those are just little tips and tricks. But realistically, as long as you can count boxes, you're golden. So flip over the x or y-axis. All points are equidistant. So that's just a super fancy word for same distance. Oh, this is called the line of reflection. So sorry. That's the main one. My bad. Ms. Sherman was struggling. Okay. So it's a line of reflection and it's equidistance or same distance from the line of reflection. Okay. All points are the same distance. So we're going to look at 4. And 4 is important solely because these, obviously, if you look at them, like this is for sure not over the y or x axis, right? Like it's really close here and it's really far here. So basically we need to figure out if it needs to be the same distance, where that line would be. So I'm going to pick the 2 points closest to each other, make my life easier. So J is 1, 2, 3, 4, 5, and 6. So these are 6 points away. So where do you think our line of reflection would need to be in the middle of that? Good. If it's a point of 6, then it's 3 on each side. 1, 2, 3, 1, 2, 3. So that is it. So this line of reflection is going to be x because it hits the x-axis. And what number does it hit the x-axis at? Positive 1. So the line of reflection is x equals positive 1. What about for this one? What about for this one? So do the same thing. Count boxes from G to G prime and see how many you get. Welcome back. 1, 2, 3, 4, 5, 6. Ironically, you get the same amount of boxes, which means you should know that it's 3 in the middle. So that means our line of reflection is going to be there. That one doesn't hit the x-axis. What axis does it hit? The y-axis. So it's going to be y equals, and what number would that be if it were to hit the number right here? Negative 1. Good job. So I want you to try this one yourself. Try this one yourself. Welcome back. 1, 2, 3, 4, 5, 6, 7, 8. So this one was a little bit different. So the middle of that should be 4, which would be here. So then write your line of reflection. What would that be? X equals 1. So vertical lines up and down always have x equals the number where it goes through the x-axis. Horizontal lines always have y equals the number where it is going through the y-axis. Great